Hi guys, Dr. Huan again. Now we are going to look at how to prove or disprove a set is a subset or a set is a subset of another set. We are given two sets. Set A contains integer n, where n is equal to 6r minus 5 for some integer r. So in other words, any n that can be written into this form, that's those numbers are in set A. And B contains the integers so that the integer is equal to 3s plus 1 for some integer s. So in other words, any integer that can be written in this form, that will be in B. Now, oftentimes I certainly encourage you to, how about just write down, try to find some elements in A. It just makes sense of A. So therefore, I'm gonna just do that. So R is integer, right? So therefore, I'm gonna just pick some R and then begin to find some elements of A. So let's look at the, say when R is 0, let's do some mental math. When R is 0, 6 times 0 minus 5, which is negative 5. So I know negative 5 has to be in A. And when R is 1, then 6 times 1, which is 6. 6 minus 5 is 1. So I know 1 is in A, right? When R is equal to 2, 2 times 6 is 12. 12 minus 5, which is 7. Okay? And when R is 3, 3 times 6 is 18. 18 minus 5, which is 13. So basically, you see every 6. That's what you see, and this would not surprise me because it's 6 times this integer, right? So it will be 6 times and minus a fixed number. So basically, if you list more, then the next one will be 19. The next one will be 25. If you go this way, the next one will be negative 11, and so on and so forth. Okay. So this actually is the, well, I don't really need to list that many. So this is basically what the set A is. Now similarly, I'm gonna just try to list a few elements from B. So when S is 0, we get 1. So when S is 0, we get 1. When S is 1, we get 3 times 1 plus 1, which is 4, right? When S is 2, 3 times 2, which is 6. 6 plus 1 is 7. And because you multiply another integer by 3, so the difference is always going to be 3. So the next one in the list will be 10, the next one will be 13, and so on and so forth. If you plug in negative 1s, 3 times negative 1 plus 1, which is negative 3 plus 1, you get negative 2. And you would not be surprised because here, 1 minus 3, you get the negative 2. So the next one in the list will be negative 5, and so on and so forth, okay? Now, so you therefore, all the numbers in set B, they differ by 3. Here, all the numbers in set A, they differ by 6. Now, obviously, more numbers like the here seems like all the numbers in A, they are in B, but some numbers in B, they're not in A, right? So that's at least after do some algebra, you have this observation. So therefore, we will see that A element set A is, do you see that set A is actually in set B? But set B is not a subset of set A. So now we need to prove that one and disprove this one by our observation. So we are going to prove this one and disprove this one. Okay, now let's talk about how to prove this one. Okay, now the method that we are using is called the elements method. So basically, we're going to pick arbitrary elements from A. Then we show these arbitrarily selected elements from A is actually in the set B. When this is done, we can say all the elements in A will be in B, because the elements we are selecting will be arbitrarily selected. So here it comes. So I'm going to say, here's my proof. So I'll begin say, let x be arbitrarily chosen elements in A. So let x be in A from A. And then what do I want to do? I want to show. So once you're mature enough, this is really, you don't really have to write it, but it's always good to keep track of that, especially for the beginners. So to show x in sets B, right? So once you show that, that will prove that A is the subset of B. Now, of course, oftentimes I always advise you to think about how can I, like what does it take for me to conclude that the arbitrarily chosen element is in B? So now we have to look at the definition of the B. B is a collection of the integers. What are these integers? The integers can be written as 3s plus 1 for some s, integer s, right? So in other words, when I see if I can show that x, in other words, if I can show that x is equal to 3 times some integer plus 1, then I can say that this x has to be in B, because that's how B is defined. So that's really actually is my goal. I want to show that x chosen from A can be written into this form. Okay, so now I'm going to begin with, so because x is in A, and what is A? This is the definition of A, so I'm going to say by definition of A, then x has to be equal to 6r minus 5 for some integer r, right? So that's because of the definition of A. Now, again, this is my goal. So I want to say x, this x, which is 6r minus 5 for some r, can be written as 3 times some integer plus 1. In other words, here's my goal. Of course, I would not write this in my formal proof. I just write this out so that I help you understand why am I doing this. So in other words, the x, which is 6r minus 5, I want it to be, I want to show that it can be written as 3 times some kind of integer plus 1, okay? That's what I'm trying to find. I need to figure out the exist such integer so that 6r minus 5 equals 3 times this integer plus 1. So therefore, basically you're solving some, just how about you just solve this integer. So if I call this integer as, say I'm going to call this integer as s, okay? Let's solve for s. So basically I need to find this integer, right? Find this integer. Find s. That's the goal. And this can be done by doing some algebra here. So you can see that 6r minus 5 minus 1 equals 3 times this s. This is, I'm just subtracting both sides by 1, and which means 6r minus 6 equals 3 times s. And therefore s is equal to, divide both sides by 3, you get 2r minus 2. So I would not write this in my formal proof, okay? I will never write this in my formal proof, but I will write that on my scratch paper. So here, in my notes, I'm gonna just move it somewhere here. This is just pretend this is my scratch paper. I do have those work here so that I know what s is. So when I write my proof, I'll say, now I'm gonna let s be 2r minus 2. Why? How can I come up with this idea? Because of the scratch, some work that I did. I know this s, I solved for s, so that this x I chose can be written as 3 times s plus 1. Now, then then first of all, we have to make sure this is integer. So now R, we already know R is integer. So 2 times R, which is product of integer, which has to be an integer. And then minus 2, which is the difference of two integers, right? So it has to be an integer. So I'm going to say let S be 2R minus 2, then S is an integer because the product and difference of integers are integer. So therefore I know that the S has to be an integer. Now I'm going to show that also, and 3s plus 1, okay, 3s plus 1 has to be in B. Why? Because look at the definition of B. B is a collection of M that can be written into this form, 3s plus 1, where s is integer, right? So therefore I'm pretty sure that 3s plus 1 has to be in B. Okay, now I want to show that now. What is 3s plus 1? It is equal to 3 times. And what is s? S is 2r minus 2. That's how we define the s. Plus 1, which is 6r minus 6 plus 1, which is 6r minus 5, right? Okay. Now, what is 6r minus 5? That's exactly what x is. So, which means this is x. Okay, we're almost done. So, what is 3s plus 1? This is an element in B, and which is actually x, right? So therefore, this x, which is 3s plus 1, has to be in B. So therefore, x is in B. Do you see that we started with x picking an element from A? Now we show that x, this chosen element, is actually in B. So therefore, according to the definition of the subset, we now can conclude, therefore, set A is a subset of B. So we finished the proof of these statements, okay? And by the way, again, this is just my scratch work. It helps me come up with how I define S. Now, let's go back to second part. We need to disprove this set B is a subset of A. So I'm gonna say, in other words, what I'm trying to say is we want to show, basically we want to show B is subset of A is false, right? Is false. In other words, you must be able to find some elements in B so that it is not in A. So in other words, there exists X in B, but X is not in A, right? So you can see that this kind of tells you the action is you are searching for such X. You're searching for such X from set B, but this guy is not in set A. And because of earlier we did the preliminary work, we do see a few of those elements. For instance, 4 is in B, but 4 is not in A, right? And then you also see that 10 is in B, but it's not in A, and there are many other ones too. So you don't need to pick many, you just need to pick one. So okay, so in other words, I'm gonna continue to write down my explanation. In other words, you need to find an integer x in B. That is an x of the form 3 times integer plus 1 and show it can be written as this form, 6r minus 5 cannot be written as 6 times integer minus 5. Okay, so that's whole my explanation. I do not need to write this down in my disproof. Here's how I would begin. You can pick any one of those that's not in B but not in A. So I'm gonna say let x be 4. That's really just the convenient value. Okay. Then and I'll say and this 4x, this x is in B because this 4 is equal to 3 times 1 some integer plus 1, right? So therefore I'm pretty sure this 4 is in B because of this reason. It is in this form. Now then I want to show 4, then 4 is not in A because of the following. Because if 4 were actually in A, I'm trying to derive a contradiction. So if 4 were actually in A, then 4 must be able to return into this form, okay? So then there exists r in integer r such that this 4 can be written as 6 times this r minus 5. Okay, because if 4 were in A, by definition of A, this 4 has to be in this form, which means 4 is in this form. Now let's do a field algebra, which means this means 9 equals 6r, right? When you add 5 to both sides, and this means r is equal to 9 over 6, or this is 1.5, okay, 1.5. Do you see that this is not in Z? This is not in Z, okay? So we actually, if 4 were in A, then there exists integer r in Z, so that this is true. But now you derive that r is actually not a integer. Do you see this is a contradiction, right? So this is a contradiction. So therefore, this cannot be true. 4 were actually in A. This will never be true. So thus 4 cannot be in A. Okay. So therefore we just found one integer, so that it is in B but not in A, right? We found integer, this guy, it's in B but it's not in A. Therefore B is not a subset of A. Alright, so this is the 2 parts. I hope that you can you are able to just cover the answer and then reproduce this proof by yourself. This certainly reflects a good understanding of the proving subsets, the skill of the proving subsets, and also understanding the concept of the definition of like these 2 sets.